So you're going into pre-calculus. Whoa! All right. So one of the first things we need to look at is remembering all this notation with functions. We have h of x over 4, and we were given an h of x function. Well, we want to replace x with x over 4. So I have negative 4, and instead of x, I'm replacing it with x over 4 minus 5. When I multiply these together, well, this is like 4 over 1, so these 4's cancel out, leaving me with a negative x minus 5. And that's it. We can't simplify anymore. On this one, we are given h times g of n. Well, remember our function operations. If this says h times g of n, well, we want to multiply these h and this g function together, and we want to keep n as the variable. So I'm going to multiply n cubed plus 5 times n plus 5. I can just distribute my n cubed to get n to the 4th plus 5n cubed, and distribute the 5 to get 5n plus 25. Look to see if we can combine any like terms, and well, we can't. We are done again. Moving on, we have f composed of g of x. Well, this is different than multiplying our two functions together. This says f is composed of g. So we have our f function, this negative 4x minus 1, and where x is, we're going to replace it, and in here we're going to plug in our g of x function. So I have negative 4 times 3x squared plus 5x, and then minus 1 at the end. I'm going to distribute my negative 4 to get negative 12x squared minus 20x minus 1. Because the 4 doesn't distribute out there to the 1. Looks like we're done because we don't have anything else we can do. So that was our f composed of g. Well, remember systems of equations. When we're solving a system of equations, we are looking for that point, that one point, or maybe many points that satisfy both of these. So when I'm looking at these, I mean, we can solve by elimination, we can solve by substitution, but to me it looks like the simplest way is going to be to multiply this entire top equation by 2 so that I can try to cancel out my y's. This is going to give me a negative 4x minus 2y equals a negative 20. The bottom equation I'm going to leave the same, because again, I was trying to get the same coefficient in front of those y's. And when I go to add these together, those y's are going to cancel out. But notice the 4 and the negative 4 also cancel out here, leaving me with 0 on the left side. Negative 20 plus 20 also leaves me with 0, so all my variables ended up canceling out, and I got a true expression. Well, so in this situation, there's not just one point that satisfies both of these equations. There's infinitely many solutions. Meaning that both of these equations are actually the exact same line, and they're not two separate lines that are going to intersect at some point. They're the exact same line, and they're on top of each other. All right, you've seen linear equations before. We obviously have the different forms. We've got our standard form, slope-intercept form, which is our go-to. We've got point-slope form. We might need to use our slope formula, and we also have facts about parallel lines and perpendicular lines. Parallel lines are going to have the exact same slope. Perpendicular lines, the slopes are going to be opposite reciprocals. So if we're trying to create the equation of a line, we always want it to be in slope-intercept form. So if we're looking at this and we are given the slope and we're given the intercept, well, all we have to do is plug it in. We know y equals mx plus b, where m is the slope and b is the y-intercept. And we're done. If we're given the slope and the y-intercept, all we have to do is plug it in. Over here, we've got the equation of a line in standard form. Well, I mean, this is the equation of the line, but it's not in slope-intercept. That's what we want. We need to solve it for y. to be in slope-intercept form. So to do this, first we need the term with y by itself. So we're going to subtract 4x from both sides. Now we have 7y equals a negative 4x plus 56. And to get y completely by itself, I'm going to divide both sides by 7. And that gives us a negative 4/7 x plus 8. Now we are in slope-intercept form. Well, we also could be given a point in the slope. Well, if we're given a point in the slope, we're going to use our point-slope form and then solve it for y so it's in the correct format. So, remember your point-slope form, y minus y1 equals m times x minus x1. We're going to plug in our point for x1, y1. And our slope is a negative 6. Now we solve for y to get it in points or to get it in slope-intercept form. I'm going to distribute that negative 6. And I'm going to add the 3 over to get y completely by itself. And now we are in slope-intercept form once again. We also could be given 2 points. Well, if we have 2 points, we don't quite have the slope yet, but we do have a point. So again, we're going to be going that route using our point-slope form. But first we can find the slope. To find the slope given 2 points, we're going to use our slope formula. And we're going to plug in 1 point. I'm going to call this second one 0.2, this first one 0.1. We know it's y2 minus y1 over x2 minus x1. 4 minus 1 gives us 3 on the bottom. 4 minus a negative 3, well, that's the same thing as negative 4 plus 3, which gives us negative 1. So our slope is negative 3. Now that we have the slope and we have multiple points to use, we can plug it into point-slope form once again. I'm going to use this point. Y minus my y-coordinate equals my slope times x minus my x-coordinate. Well, I'm going to distribute my negative 3. This is the same thing as x plus 3 on the inside. And so I have negative 3x minus 9. I add the 1 over. And so the equation of this line is negative 3x minus 8. Again, solve for y so it's in slope-intercept form. Finally, we could be given a point and then we're given some equation that might be parallel, it might be perpendicular. Well, remember, if it's parallel, the slopes would be exactly the same, but since this one is perpendicular to this line, we know our slope is going to be the opposite reciprocal of that. Well, the opposite reciprocal of 3 over 2 is a negative 2 over 3. And so now we have our slope. Our slope is that negative 2 over 3, and we have a point. So again, I'm going to use point-slope form. Y minus my y-coordinate equals my slope times x minus my x-coordinate. And again, I'm going to solve for y. Distribute that negative 2/3, gives me a negative 2/3 x plus 2, and I'm going to add 3 to both sides to get y equals a negative 2/3 x plus 5. So that's everything we've really talked about with linear equations as far as writing those equations. All right, so we want to graph this linear inequality. Well, in order to graph anything linear, I would always try to get it solved for y, because once it's in that slope-intercept form, it's nice and easy to graph. So to solve this for y, I'm going to subtract x from both sides. We have 5y is greater than negative x minus 20. Divide both sides by 5. And y is greater than a negative 1/5 x minus 4. Well, to graph this, we know our y-intercept is a negative 4, and we know the slope is a negative 1/5. I'm going down 1 over 1, 2, 3, 4, 5, and I could plot 1, 2, 3, 4, I have a point over here on the left side too. Well, notice for this inequality, it's strictly greater than, meaning that we do not have a solid line, but we will have a dashed line that connects these points. And we need to shade one side or the other. So I'm going to try 0, 0. I'm going to see, does this point work? When I plug in 0, 0, I get 0 is greater than -4. And since this is true, I'm going to shade this side of my line. You always want to shade the side of your line where the points satisfy our inequality. We know we cannot consider something simplified if it has an imaginary unit or if it has a root in the denominator of a fraction. So we have to get rid of it, and in both of these problems, we want to use our conjugate. So I'm going to multiply the top and the bottom here by the conjugate of the denominator. This would be x, or sorry, not x, but 10 plus 6i. When we multiply the top and the bottom by the conjugate, well, the top, I'm going to distribute the 9 times 10 and 9 times 6i. This gives me 90 plus 54i. When I distribute the 7i, I have a negative 70i and a negative 42i squared. On the bottom, I distribute my 10 to get 100 plus 60i, the negative 6i to get a negative 60i minus 36i squared. When I combine some like terms, I've got on the top 90 minus 16i, and I have minus 42i squared. On the bottom, these 60i's cancel out because one's positive, one is negative, to give me 100 minus 36i squared. And notice we have I squared on the top and the bottom. I squared is a -1. So I'm going to replace that with a -1. Now, 100 minus 36 times -1, 36 times -1 is a positive 36. So on the bottom, I now have 136. On the top, negative 42 times -1 is a positive 42. And when I add that to 90, 90 plus 42 gives me 132. And I still have that negative 16i. And we can leave our answer just like that. Over here again, we want to get rid of this using our conjugate of the denominator, because we do not want a root in the denominator. So I'm going to multiply the top and the bottom by 9 plus the square root of 3. And I distribute just like normal. Negative 7 times 9 is a negative 36. Negative 7 times the square root of 3 is minus 7 square root of 3. Negative square root of 2 times 9 is a negative 9 square root of 2. And negative square root of 2 times a positive square root of 3 is a negative square root of 6. On the bottom, I distribute the 9 to get 81 plus 9 square root of 3. I distribute the negative square root of 3 to get negative 9 root 3 minus the square root of 9. On the top, notice there's nothing in common. There's nothing I can break down, I can do anything to, so the top is going to stay exactly the same, but it's the bottom that we're going to be able to simplify. On the bottom, we have 9 root 3 minus 9 root 3. Those cancel out. And we know what the square root of 9 is. This is saying minus 3. So on the bottom, we have 81 minus 3, which gives us 78. And we can't do anything else. Can't simplify this anymore, so we leave it the way it is. We don't have a radical on the bottom anymore, so we're done.